Excellent. All right. So let me just move some stuff out of my way here real quick. And thank you everyone for joining us here for architecting Cisco ACI in the AWS Cloud. So essentially what we're looking at is building a hybrid cloud where we have our on-prem devices communicating with our AWS or our cloud devices. So obviously you can have more than just AWS, but here we're going to be focusing on AWS. Now, the first thing that I want to do before I really dive in here is I want to start talking about what ACI is, application-centric infrastructure. I'm going to pull up this really expensive whiteboarding utility here. Let me get a new page here. There we go. I'm sure you guys have seen this. It costs like $2,000 to buy. But let's start talking about just real quick what ACI is. And then we're going to talk about the major components that build the ACI communication path over to your AWS cloud. Now, this isn't a super deep dive, but I do have some takeaway stuff for you folks. So I do have a link that it's essentially the white paper. It will show you from start to finish exactly what you need to do from an ACI and AWS perspective. Here, we're just talking about how do we get that communication path up and running and what's the whole point. So the first thing is ACI. So, back in the day, what we used to have is we'd have these routers over here and we would connect them over here to a couple of segments. And then we would have maybe a workstation or a server. Now, back in the day when dinosaurs roamed the earth, right? What we would have to do is we would have to go to each one of these interfaces and configure VLAN association. VLAN association, quality of service, port security, right? So that maybe these guys would be in the same or different VLANs. The next thing that we had to do is we had to set up those trunks. We had to have some way to allow these two dissimilar segments to be able to talk to each other. And that was usually done with routing. So what are we going to have to do? We're going to have to configure routing over here. Okay, so what a drag, right? Not a fan. So what we did was we developed a new type of network infrastructure and a new methodology for configuring that network infrastructure. What we were really trying to get away from here, folks, was having to touch every single one of these points, right? If I had the ability to take all of this and have something else do it for me, boy, that would really reduce the amount of work that I have on a day-to-day basis. And no, it's not taking your job. It's just making you faster at it, right? So here's what we did. So first, we developed Cloud Architecture, which is essentially that spine leaf architecture. We like this, because it provides that equal cost multipathing. It allows us to load balance and have fault tolerance from that client to that server. Now, with that said, that's just from a physical perspective, right? So physically, we already increased, efficiency on the network, but we got to start taking a look at how are we going to start doing this somewhere else. So I'm sure you folks probably remember back in the day where you would connect to a switch and then maybe copy and paste a script, right? That's supposed to be a script, by the way. I'm sure you've copy and pasted a script into a device to configure it, right? Well, that was normally held inside of good old file server. What we're doing today with ACI is we're using this guy here with a face placed one time. This is called an APIC, an Application Policy Infrastructure Controller. Normally we plug it in redundantly. Now, what the APIC is going to do for us, first and foremost, it's going to do discovery. It is going to discover all of these leaf and spine devices, and it is also going to discover the links between them. This is what's going to give you your equal cost multipathing. But that's not it. One of the biggest pieces for the APIC for us in ACI is policy. What we are going to do is we are going to build policy inside of the APIC, identifying, first of all, our applications that are running across this ACI fabric. Second of all, are they allowed to communicate? So inside that policy, we have a couple of different things. So I'm actually going to delete this over here just to get a little bit more room. So what we're going to create is what's called an application network profile. This is an application network profile. Inside there, we are going to define our applications. Okay, that says web, I promise. We'll call this an app server and this a database. Now, these are what we call endpoint groups, EPGs. Endpoint groups, what they do is they simply just group devices running a similar application. That's it. That's all they do. So that we can now create this cool thing between them called a contract. Now, this contract, honestly, folks, it's an outbound and an inbound ACL. That's it. That's all we're doing. We're creating that application network profile. By the way, there are a couple of other things. We do have to enable layer 3 across the fabric, and we call that a VRF, right? You can create up to 1,000 VRFs per tenant inside of ACI, so it doesn't have to just be one. But then we also have to create our broadcast domain, VLAN, subnet construct. These are called bridge domains now. So what we'll do is we'll overlay this layer 2, layer 3 construct in each one of these switches. So now they can see the downstream networks. They can route between them with a layer 3 engine on the multi-layer switches of the ACI fabric. But what's more important is once these guys start communicating. So actually, you know what, we'll say that this is a web server over here trying to talk to an app server. This is very, very important. When the web server communicates through this leaf node for the first time, it has no idea what to do with the traffic. So what is it going to do? It's going to ask, well, the leaf is going to ask the APIC, do you have a traffic pattern from this bridge domain to this bridge domain using this source application to this destination application? Well, it's going to say, you know what? Yeah, I do actually. And here's a contract permitting the specific port. If that's permitted, hey, go ahead and instantiate, or if you remember, copy and paste that config. Yeah, instantiate that configuration right here on the port. So that means that now this web server should be able to talk to any app server within that specific bridge domain. Hey, we do a lookup for the destination and we'll just say, pow, we send it to the destination. And again, here on this destination port, we'll go ahead and build or instantiate policy that allows us to permit that traffic and build things like VXLAN tunnels inside the fabric to keep traffic separate. So again, what we did with the ACI is all of those touch points are now being done with the APIC. Now, let's dive into the slideshow, into the tech talk here, where what we're trying to do now is over here. Well, let me delete some stuff here. So now what we're trying to do is connect this to a cloud. I want to be able to instantiate these same policies over here for my virtualized environment. So we're going to talk about how we create that communication path between AWS with your AWS connector and the ACI fabric, well, ACI Direct Connect. So first thing we're going to talk about is the components that ACI is going to be utilizing to communicate from the ACI fabric over to your AWS cloud. So this is just ACI. ACI is obviously going to use that application policy infrastructure controller. The whole point of that is going to be that single point of policy configuration and management. And I do want to make a note here real quick. A lot of people get hung up on what the point is of the APIC inside of the AWS Cloud. I'll get to that, but its major, its major job is to learn your virtual nodes inside your AWS Cloud. Now, we also have this thing called a multi-site orchestrator. Now, you've probably heard of UCS Director. We used to utilize UCS Director to talk between different ACI data centers. But the multi-site orchestrator is what gives us the ability to talk to an on-prem and cloud environment. The whole point of this is to connect your ACI on-prem and your cloud into one singular dashboard so that I can send out consistent policy across the physical and logical clouds. Okay. So a quick note here is that the communication between the APIC and the multi-site orchestrator is not available with APIC version 4.0 and lower. You must be running ACI release 4.1 and higher. So like, for instance, our 3.0 series, that's what gave you your multi-site, multi-pod. The 4 series is what gave you your multi-site orchestrator capabilities. Okay, essentially hybrid cloud capability. Oh, okay. Looking at this architecture from a high level overview, you'll notice the multi-site orchestrator sitting here. And actually, here we go. So you'll notice the multi-site orchestrator sitting here up at the top. This is going to be your single pane of glass, right? Your dashboard. You'll note that we have 2 on-prem. So these are essentially physical data centers, right? And then you also have maybe a couple of AWS cloud sites. What I want you to note here is these blue things. These blue things are your APICs. So I want you to notice you got 3 APICs at each one of these sites. Then what you're going to do is install the cloud APIC with a Cloud Foundry template inside of AWS. This is what allows us to start learning these AWS devices and gives us the ability to now instantiate policy from a physical data center to a logical data center. Okay. Now, moving forward here. So what are some of the challenges that we run into? So the main challenges in building this is automating the creation of secure interconnections between the on-prem and public cloud. We're going to show you how we're going to be using EVPNs between the sites and BGP EVPNs and IPsec. We also, we've got to deal with diverse and disjoint capabilities across the on-prem and private cloud. What we mean by that is there's certain things that we're doing inside the physical cloud, inside of your on-prem, that we're not doing inside cloud, right? A perfect example is, my on-prem cloud, a lot of customers are doing this. My cloud, my AWS cloud might just be all of my web servers, right? They're forward facing, they're public facing, right? Perfect for the cloud. But then inside of my private cloud, inside of my AWS infrastructure, that might just be the applications that we use internally and my app and database servers, right? That need to be physical. So they got that horsepower, right? So another thing is multiple panes of glass, right? Okay, do we want to have an APIC up and an AWS console up? Or we could just have a multi-site orchestrator on, right? Inconsistency or inconsistent security segmentation. This is super important because in the ACI on-prem, I have microsegmentation. I can install an AVS, an application virtual switch, or an application virtual edge, and I can do microsegmentation at the virtualization level. We really didn't have a lot of that between being able to segment between the cloud web server and segment that to the on-prem server. We do have that now. The learning curve. Okay, well, you know, that's I like to think that's kind of arbitrary, but there is a little bit of a learning curve, especially if you've never worked with a cloud infrastructure before. And then L4 through 7 services. This is super important. My ability to be able to automate the implementation of a firewall, SSL offloader, or a load balancer without having to corral traffic with VLANs and routes, super, super important. And we have that. So the Cisco Cloud ACI on the AWS Architecture. So what are we doing again? We're utilizing, if I can find my pointer here, there it is. We're utilizing some sort of layer 3 IP network to allow these guys to talk. Keep in mind that we are implementing an APIC at that site so that we can learn and instantiate policy. So the policies that you are instantiating today here on your ACI fabric can communicate across the IP network over to another APIC and be instantiated into your Amazon Web Services. I like that. Now, this is a little bit more information on the multi-site orchestrator. I'm not going to spend too much time on that. The Cloud APIC, this is more information on how do we spin up that APIC inside of your AWS Cloud. Right here, folks. What you're going to do, the software-only solution is deployed using cloud-native instruments such as cloud formation templates on AWS, right? So you're going to download the APIC image, and then you're going to implement that as a cloud formation template that you can then deploy in your EC2 instance. This is just a little bit more information on how we're going to create a virtual private cloud utilizing things like CSR 1000 Vs for communication for IPsec between the AWS Cloud and the ACI Cloud. You're also going to be using AWS virtual private gateways to provide more internal security and security groups and rules. And rules, here we go, inside of the AWS Cloud to provide internal security. Remember, this is all about allowing, using an IP network to allow APICs to talk to APICs so that they can have a consistent communication path. Or, I'm sorry, consistent policy. So the first thing we're going to do is the Cloud APIC is going to provide that northbound REST interface to configure your cloud deployments. So the northbound REST or representative state transfer interface is really the communication path up to the multi-site orchestrator. And so once you get that implemented, the APIC is going to accept the policies. Well, there we go. It will accept the policies from the multi-site orchestrator. I do want to mention that if you have multiple machines in the same subnet as your APIC, you can use those machines to connect directly to the APIC inside the cloud. This isn't something where you can only build it out through the multi-site orchestrator. You absolutely can directly connect to it through one of the virtual machines inside of your VPC. As I mentioned again, it is going to perform endpoint discovery. It is also going to build policy translation. You're going to see in the next couple of slides here where one policy like an EPG means or is termed something else inside of AWS. All we're doing is we're converting the constructs that we already know, bridge domains, EPGs, application network profiles, contracts, into something that AWS understands. So you're automating the policy your AWS policy creation via using the APIC. And I'm just going to step back for a second here. I do want to mention here, guys and gals, that this is very similar to a VMM domain. If you're not familiar with a VMM domain, let me pop that into the chat window here. So Cisco ACI VMM domains. I would give that a look. because what VMM domains do is the exact same thing. They convert the ACI policy, EPGs, bridge domains, VRFs, and contracts into port groups and security constructs that ESXi uses. We're using the exact same methodology over here inside of your AWS Cloud. So if you're familiar with VMM domains, that's all we're doing here, folks. Now, another thing is, yeah, we can configure our cloud, our CSR 1000 Vs control plane. So yes, you can configure it. And then the big one here is configuring the data path between the ACI Fabric and the cloud site. Now, just a little bit more information. Yes, you are going to deploy this across an EC2 instance. And what's really, really important is that you're using EBS, Elastic Block Storage, here inside of your AWS Cloud. It requires that. The Amazon machine for the APIC are available in the AWS Marketplace using that Cloud Foundation template. And also there is this bring your own license model for licensing that AWS supports. So if you already have a license for these components, you can just implement them right then and there inside of the AWS Cloud. Good guy AWS strikes again. So one of the most important pieces here is taking these things that we already discussed. This is my application network profile. These are my EPGs and here are my contracts. How do I translate them into something that AWS understands? By the way, again, this is a main function of a VMM domain. We are essentially creating a VMM domain inside of AWS. So here it is. So for instance, an EPG, and excuse me, one moment here. Let's go over here. Let's look at your EC2 instance on your security group firewall. What they're doing is they're creating these contracts, which isn't really what we use. We call them security group rules, right? And then we also have our EPGs. Well, those are called security groups, right? So what you're doing is when you push the policy from the APIC, what you're used to seeing, your application network profile, EPGs and contracts, when you push that down to AWS, it doesn't see it as contracts and EPGs. It sees it as security groups with security rules between them. That is the major, that is the major function of the APIC, the cloud APIC. It translates the ACI native constructs into an AWS readable, understandable construct. Now, what does it look like when we start building this out from an AWS perspective? So the first thing you're going to have here is you're going to have an infrastructure private cloud, virtual private cloud. This is where your CSR 1000 Vs live. That's your infrastructure. These guys are what's going to be talking back through your internet gateway using IPsec and BGP EVPN. The BGP EVPN is what allows us to take policy from our cloud MSO, your multi-site orchestrator, or on-prem, so they can talk back and forth. So this BGP EVPN allows us to communicate that policy requirement over to our cloud APIC. So these CSR 1000 Vs are super important because that's what creates the connectivity between us, the cloud APIC, and the rest of the world. So very, very important. Please note that we do have them in a redundant pair for fault tolerance and load balancing. Downstream, we have our virtual gateways. These virtual gateways are essentially security constructs, kind of like a firewall inside of AWS, that allows us to create an IPsec tunnel for security purposes between the CSR 1000 V and the internal virtual private clouds. So these are our applications. These are our users. here's just another example of just a couple of different ways that you can implement it. So this can be highly redundant in this last example. But yeah, they just made it redundant. Here, this is more of from a AWS perspective instead of the CSR 1000 Vs. All right, another thing that I want to mention here is that you can create multiple regions. This is a question that I get a lot is, you know, how do I deal with multiple regions? Guess what? As long as they have some sort of IP connectivity between the regions, the APIC absolutely can see everything inside here and everything inside here. Rocking and rolling, bop around. Okay, what about the underlay network? This is what I was talking about here, folks. So what you're doing is the CSR 1000V is actually creating a VPN connection over to the, this is actually our CPR customer prem device with 4.1 and higher. These are actually going to be plugged into your spines, believe it or not, right? Probably something we're not used to seeing, but yes, this is going to plug into your spines. You're going to enable OSPF between the spine and I don't know, the ASR 9K, whatever you're using for the edge. And then you'll create an IPsec tunnel between that device and your CSR 1000V. The next thing you're going to do is to allow communication via AWS. You're going to use the AWS Direct Connect. I call it the Direct Connector, you know, because that's just what I call it. But yeah, this is essentially what allows the AWS site to look like a co-location. Okay, sorry about that. Okay. All right, there we go. Let me switch that around. Sorry about that. I have no idea how that happened, but okay. Now, beautiful. This is one of the last things that I wanted to show you here is how are they communicating? How does a web server over here talk to an application server over here? It's actually pretty simple. Again, you're going to build the EVPN session. This is what allows policy to move from these APICs through the CSR 1000V to this APIC. And likewise with a multi-site orchestrator, right? The VXLAN is the actual data being transported. So this is an actual application server request leaving the web server and going to the app server. So it's actually pretty simple. Yeah, you're just using a BGP EVPN, Ethernet VPN, and a VXLAN tunnel for each communication. And this is all running over an IPsec tunnel across some sort of layer 3 environment. Okay. Groovy. Okay, at this point, I am going to open it up for Q&A, but before I do that, I do want to throw out this link here. If you folks can bring up your, chat window. All of that information came from Cisco's white paper on how to implement ACI or AWS and ACI together into a hybrid cloud. This is the full white paper on it. That is not only just going to show you, and actually let me bring this up just to show you. So here we were just talking about how you know, these guys are talking AWS Connect, you got your BGP EVPNs, and if you keep moving forward, it's going to show you how to build your bridge domains and EPGs. So how is the logical network constructs instantiated here inside of the Cloud APIC, and then going all the way down here, these are all the different use case scenarios. And then here's the actual deployment. It walks you through, okay, go to your AWS console, right? Go ahead and create that APIC, right? Go search for it and create it, right? Run that first time wizard, right? So it's going to run you through, if you folks want to do this, this is going to run you through the full implementation. With that being said, Thank you guys very much. We are now in our Q&A session. Please let me know if you folks have any questions.